Welcome. Dear students, today we are going to discuss hydrogen bonding. To understand hydrogen bonding, we have to first discuss the molecule of hydrogen fluoride and how hydrogen bond exists between these molecules. Let us discuss hydrogen fluoride. Consider this as the atom of hydrogen and consider this as the atom of fluorine. Hydrogen requires one more electron to complete its duplet and fluorine requires one more electron to complete its octet. So they go for a mutual sharing of electron. This mutual sharing of electron between these atoms is referred to as a bond. Covalent bond is formed. But there is a problem here. Fluorine is of different nature from hydrogen. Fluorine is electronegative, that is, it tends to withdraw electron towards itself. Hydrogen is not so. With the result, what happens? The shared pair of electron actually moves towards fluorine. The electron cloud moves towards the fluorine. And because of this, a negative charge develops on the fluorine end and a positive charge develops on the hydrogen end. This is scenario number 1. In scenario number 2, consider that I bring another molecule of hydrogen fluoride near to it. This is the other molecule. Here also same situation persists. This side is positive and this side is negative because fluorine tends to withdraw the electron. These charges develop. Now if I bring them close to each other, what happens? An electrostatic force of attraction comes into play. The positive end of the one molecule attracts the negative end of the other molecule. A dipole-dipole interaction takes place. A kind of attraction takes place between oppositely charged centers of different molecules. This attraction is referred to as hydrogen bonding or hydrogen bridge bond. Hydrogen bonding or hydrogen bridge bond. Here, if you can see, the hydrogen actually acts as a bridge between two electronegative atoms. See, it is attracted to this atom also, right? It is attracted to this atom also. So it is attracted to both atoms and it is a bridge between both these atoms, right? Both the electronegative atoms. Therefore, it is called as hydrogen bridge also. Now, the bond between HF is very big. It's very energetic. This is not so strong. Hydrogen bonds are weak. It's just a force of attraction. Nothing else. It's not a bond, it's a force of attraction and it is very weak compared to the covalent bond energy of the HF. Okay. Now let us see, this is the scenario when hydrogen is attached to electronegative atom. This is the scenario. Now the question before us is, do all the compounds that have hydrogen, do they show hydrogen bonding? For example, CH4. Do they show hydrogen bonding because it's having hydrogen? C2H6, does it show? C3H8, does it show? C4H10, does it show? Okay, benzene, does it show? Cyclohexane, does it show? The answer is no, because here there is no polarity. Carbon and hydrogen both are having same electronegativity. So therefore the electron, the shared pair of electron is always at the center. Okay, it's not deviated towards any of the atoms. So here these are non-polar compounds completely. So being non-polar, no charges are there. Hydrogen bond do not exist in these conditions. So in which hydrogen compounds hydrogen bond exists? The answer is hydrogen bond exists in compounds in which hydrogen is attached to electronegative atom. Okay, it can be a halogen atom, it can be nitrogen atom, it can be oxygen atom, right? All these are electronegative atoms. If hydrogen is attached to electronegative atom, only then only such compounds will show the hydrogen bonding. Okay, let us see what is hydrogen bonding. Okay, here just look at this. Yes, bond etc. This is hydrogen bonding. See this? Yes. Hydrogen bonding is the electrostatic force of attraction. This is the electrostatic force of attraction. It is the electrostatic force of attraction between hydrogen which is covalently attached to electronegative atom and a hydrogen bond acceptor. Fine. What is hydrogen bond? What is hydrogen bonding? Hydrogen bonding is the electrostatic force of attraction that exists between hydrogen bond between hydrogen atom which is covalently attached to electronegative atom and a hydrogen bond acceptor. So it's a electrostatic force of attraction between these two, right? Hydrogen and hydrogen bond acceptor, provided hydrogen is attached to electronegative atom. So that is hydrogen bonding. As I told you, compounds that are having NH, OH, right, XH, they will show hydrogen bonding. Let us see example. OH. See, look at HOH, water. It shows hydrogen bonding because it has OH. Look at ROH. It shows hydrogen bonding. RCOH. It shows hydrogen bonding. What about phenol? That also shows hydrogen bonding. Correct? All these compounds are having OH. All these compounds will show hydrogen bonding. Now let us see examples of NH. NH3 shows hydrogen bonding. RNH2 shows hydrogen bonding. R2NH shows hydrogen bonding. RC double bond O NH2 amides, they also show hydrogen bonding. Here also we can see that in hydrogen is attached to the electronegative atom, right? So all these compounds having NH, they also show hydrogen bonding. The other example is halogen, right? Look at HCl, HF, HI, HBr. All these compounds will show hydrogen bonding because it is attached to a electronegative atom. Now, as I told earlier, hydrogen bonding is not equivalent to covalent bond. See, OH bond, covalent bond is 110 kilocalorie per mole. But hydrogen bonding, okay, hydrogen bonding between these two, right? That would be only 8 kilocalorie per mole. So hydrogen bonding is actually very weak. It's a weak intermolecular, weak electrostatic force of attraction. Nothing else. There is no bonding. Now, it is similar to, and you can say if you rub the balloon on your hair and then you stick it to the another balloon, it will stick to each other. So there also electrostatic force of attraction comes into play, right? If you take the comb and if you rub it in your hair and if you are bringing it near to bits of paper, then the force of attraction comes into play. The bits of paper, they get attracted. So in the same, that is electrostatic force of attraction. There is no bonding here. Okay. Now let us come to types of hydrogen bonding. There are two types of hydrogen bonding. Number one, intermolecular hydrogen bonding. Intermolecular hydrogen bonding. We will see intermolecular hydrogen bonding here. Also we will see its influence on physical property. For this, let me draw. See, look at this. You will come to understand. This is water molecule. Hydrogen bonding that exists between molecules of the same compound is called as intermolecular hydrogen bonding. All this is same, all are water molecules, and hydrogen bonding between these molecules are referred to as intermolecular hydrogen bonding. You can see another example, ethanol. Look at this. This is also example of intermolecular hydrogen bonding, right? Yes. So because this all are same molecules of ethanol, between them hydrogen bonding is called as intermolecular hydrogen bonding. Now what is its effect? Intermolecular hydrogen bonding, it increases the boiling point considerably. It increases the boiling point considerably. The boiling point of water is surprisingly very high. The boiling point of this ethanol is high compared to other molecules of the same molecular weight. If you are taking dimethyl ether, it is having same molecular weight as that of ethanol. If you are taking N-propane, it is having same molecular weight as that of ethanol. Okay. Their boiling point is comparatively low, very low as compared to ethanol, because ethanol depicts intermolecular hydrogen bonding. Why? We will study that, why it is so. For that, we first need to see what is boiling point. See, boiling point is the temperature at which vapor pressure of the solvent is equal to atmospheric pressure. Okay, atmospheric pressure, 1 atmospheric pressure, right? So when this vapor pressure becomes equal to atmospheric pressure, boiling takes place. Okay, this liquid is converted into the vapor form. For this, temperature is to be required. We need some temperature. When a temperature rises, the vapor pressure of the solvent becomes equal to atmospheric pressure, and only then the molecule convert itself into the vapor phase. Right? Now, for ethanol, like molecules, this is yes. Look at this, the ethanol intermolecular hydrogen bonding. If it was a normal molecule, if it is normal molecule, okay, what would be the boiling point? Normal molecule, that is, there is no hydrogen bonding. What would be the boiling point? Temperature that is required for the vapor pressure to become equal to atmospheric pressure. If it is a molecule that depicts intermolecular hydrogen bonding, that shows intermolecular hydrogen bonding, in that case, what would be the boiling point? The boiling point will be this plus the energy required to break these intermolecular hydrogen bonding, right? This plus this energy, that is, first it should be this only. Which one? First it will be the energy required to break the intermolecular hydrogen bonding plus temperature at which vapor pressure is equal to atmospheric pressure. So temperature required to break intermolecular hydrogen bonding. So that is the boiling point of compounds that depict hydrogen bonding, and this is the boiling point of compound that do not show hydrogen bonding. So for compound that show hydrogen bonding, extra energy is needed to break these intermolecular hydrogen bonds. So that is why the boiling point of those compounds that show hydrogen bonding become considerably very high. Now let us look at the second type of hydrogen bonding, which is intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Yes. Any idea? The name itself suggests. What is it? Yes, it is the bonding between two different molecules. It is the bonding between molecules of two different compounds. Let us see. HOH, right? And HOC2H5. Look how water and alcohol mix with each other. You can surely show the charges here because of which they are getting attracted. This is the first time I am showing. I have not shown in the previous example, but you surely can show the charges. Yes. So how you can see that how ethanol, which was showing hydrogen bonding, it is a solute, right? How it is soluble in the solvent? So solute which show hydrogen bonding, they are soluble in solvents which show hydrogen bonding. What did I say? Solutes which show hydrogen bonding, they are soluble in solvents which show hydrogen bonding. How they are soluble? They can break into the sequence. Correct? See, this was the earlier sequence between water molecule. What did our C2H5OH did? it broke into this sequence, right? It broke into the sequence and formed hydrogen bonding links with water, right? It broke the sequence and formed hydrogen bonding links with water. So in this way, the ethanol molecule is completely solvated with water, right? Even we have seen in our previous class the carbocations, R plus carbocations. It is also completely solvated by water. If you want to know more about carbocations, do refer my earlier video on SN1 and SN2 reactions, and as well as you can refer the protic and aprotic solvents. So in that we have seen how carbocations are solvated by water molecules. So here I am showing you this. All polar molecules can be soluble in water, because water, it can depict hydrogen bonding, it can show hydrogen bonding with polar molecules. So, and polar molecules can break the sequence of water molecule and get inside it and effectively get solvated. Dear students, that ends hydrogen bonding. We have seen hydrogen bonding is a kind of electrostatic force of attraction. It's not a bond, and electrostatic force of attractions are very weak, but they have a big influence on physical properties, especially boiling point as well as solubility. If you have liked the class and if you have understood, please do not forget to subscribe this channel. Thank you very much.